So next up, I actually want you to try one by yourself. Obviously not with a partner, unless you have a friend who's in the class who's living with you. If your brother or sister lives in the class, is taking the class at the same time, you can do it together. But yeah, so try this out. Pause the video and try. Yeah. Okay, welcome back. So hopefully you were able to solve this. So one thing, I'm going to go over this fairly quickly, and mainly so that you kind of see how to solve this, so that when an exam kind of situation does come up, you kind of see what Aram expects for this solution. So what we're going to do first off is we break this up into 3 different portions. So here I do this, minus 1 to 3 e to the x dx plus 1 to the 3 1 over x dx. So notice how I used the properties from, let me look this up, from proposition 1212. And in particular, I used the properties 5 and 6. 5 and 6. In case you want to look that up. I have the cheat sheet in front of me while I'm talking to you guys. Mwahaha. I am evil. And so here we take the derivatives, right? Or we take the integral, sorry. And so we get 4 times x to the 4 over 4 from 1 to 3 minus e to the x from 1 to 3 plus the natural log of the absolute value of x from 1 to 3, right? So this, if you end up calculating it, unless I have an error in my calculation, which is very likely, this does happen, you should get something like, you should get this as your solution. So if you got that, congrats. If not, work a little. So I would expect to show more work here. Show more work. But other than that, these first 2 steps are good. This is okay. This is okay. This one, you'd need to show more work afterward, yeah? Okay, so now with all this, what we're going to ask ourselves... yeah. So what we're going to ask ourselves next is, how do we find these antiderivatives? Is there an easier way to find these antiderivatives so that we're not sitting here breaking all these functions apart, kind of like what we did here? So basically, I kind of want to skip these 2 steps, and I want to go here. All right, I want to find some function where I just need to plug in, right? I want to basically make this faster. And the question is there a way to do that? And this is what the question of indefinite integrals aims to solve. So indefinite integrals, this is one of the big things you'll be working on in the next semester. And that's how to find antiderivatives. So for example, if I have this function here. So let's look at an example. Let's make this green. And we're going to look at this example here. And in particular, I have a function f such that f prime of x is equal to f of x is equal to e to the x squared. Yeah. So in case this is a little confusing, this is this. Yeah. And so this is very difficult. Is it this? Do I want the other way? Fudge. I think actually, no. I think what we want... I think it's this. Yeah. Yeah. So this is a fairly difficult question to answer, yeah? We don't actually have the tools to be able to answer this. But at the end of your next semester, you should be able to answer this. You'll gain enough tools to be able to do this. And so my goal is to start you on this path so that you can be super strong, so that when you get to the next class, you're ready to destroy. Even if you get a teacher that's not the best at explaining things. Hopefully you'll be able to learn things and be able to grow from there. So let's look at this. So what is an indefinite integral? Let's actually talk about this. So what's an indefinite integral? So an indefinite integral is the set of all antiderivatives of a given function. Well, we've already seen this, right? In other words, it's just the general formula f of x plus c. So we've seen this actually multiple times. And we've been doing this for like homeworks and in other places. So normally what we do, so we're actually going to denote this by this. Okay? And so actually maybe I should put this on the other side. Bloop, 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 bloop. Ah, what the bananas. There we go. This is equal to f of x plus c. And so basically what you're going to notice is that they're kind of the same, right? So the main difference, so you're going to notice that this is similar to definite and indefinite, to definite integrals. But here I've highlighted this note, and this is a very important note, right? And it's basically looking at what's the difference between definite and indefinite integral. This is what we just defined. This is indefinite, finite. And then if I add my limits, my lower and upper limit, then I get a definite integral, definite. And that's because this will give us a definite answer. I know exactly what the answer is. This one, I mean, I don't really know, right? Because I'm not telling you where my box kind of starts and ends. So this is not really telling me too much. It's just giving me a general solution, but it's not telling me exactly what the solution is. So it's indefinite. And so what can we actually talk about for these things? Well, we have 1.5 million properties. Like you can literally see, we have 1.5 million. There's 19. And so let's look at some of these, right? So some of these should be fairly easy to see. One is we can pull constants, like having a constant isn't going to matter. We can pull constants out. Addition kind of carries naturally over. So like here, let's think about this. What's the antiderivative of x to the n? Well, this is just x to the n plus 1 over n plus 1, but we want a general solution, so we have this plus c. Okay, how about 1 over x? This is just natural log of x plus c, because we're talking about the general solution. How about e to the x? Well, this is just e to the x, but we want a general solution plus c. Notice how I am always adding a plus c. Even in the first case, I have a plus c. And remember, this is because if I have some function, right? If I add c, this was pretty bad drawing, but you kind of get the idea. If I have the same derivative everywhere, right? These are all the same derivative. I can just move the function up and down and the derivative is the same. And so we need this plus c when we're talking about indefinite integrals. So here, I'm going to say this. Always have plus c with indefinite integrals. Like, I've definitely seen some teachers where they will remove 50% of your grade if you do not add this plus c. That is how important this plus c is. So it is important. Remember this plus c. Like, plus c, make a little happy face if it helps. I don't know. Like, but remember plus c. Anyway, let's go back to our properties. So here we have the integral, the indefinite integral of sine of x. So what's an antiderivative? This is just minus cosine of x plus c. How about cosine of x? Well, this is just sine of x plus c. So notice how, remember, each time here, these are antiderivative. So antiderivative. And then we add plus c. Yes, I know I said the same thing 600 times, but that's because I promised there will be people who forget. That might be one of you who does forget. I know I forgot a few times when I did my exams. So remember these things. And then the other ones, they're all basically things we've seen before. So I'm not going to go over them too much, but just notice how every single one has plus c. Okay, so who cares? Is this actually, what's the point? How does this help us when it comes to antiderivative, to definite integrals, right? All of this we're doing in order to help us with definite integrals. So the question is, does this actually help us find a way to solve definite integrals? And kind of. So for now, yes and no. Right now, we don't necessarily really have the answer. But we can kind of see it from here. So let's look at this example. So we want to do the here I can zoom in. I got room. We'll do it here. Bam. So what do we have here? So here, what's the antiderivative of 1 over x cubed? Well, this we know is, so it's 12 times, this is 1 over x squared. Here, actually, let me do this slightly differently. I'm going to make this a little bigger. The rewind. So we're going to do 12 times. And then here, 1 over x cubed, right? This is just equal to x to the minus 3. So the antiderivative, so this, right? This is just x to the minus 2 divided by minus 2. So this is just minus 1/2 x squared plus c. Look, even I'm a failure. Remember this plus c. Okay, so what do we do here? But what this does is, when we plug in this antiderivative, we actually do something we're kind of not supposed to, and this is where this confusion kind of lies, is we forget about the plus c. And you'll actually see why. I'll put the plus c in for now, and you'll see why we don't actually need to worry about it. So here we have, what do we have? Minus 1 over 2x squared plus c from 2 to 4. You would lose points here for most classes if you put this. We'll lose points for plus c. Because here we're not asking for the indefinite integral. But for now, I'm putting this in to show you why we don't need this. So what is this equal to? This is 12 times, well, stop moving. Minus 1 over 2 times 4 squared plus c minus 1 over 2 times 2 squared plus c. So what, oh my god. I swear today this thing hates me, is equal to 12 times minus 1 over 4 times 4 is 16 times 2 is 32 plus c. Minus is plus. 1 over 2 squared is 4 times 2 is 8 plus minus c, right? Minus plus is minus. So these plus and minus c's cancel. This is why we don't need this plus c. It doesn't really do anything. It just makes us work more. It's technically correct. It's just more work. So why do it? So what do we end up getting here? What do we end up having here? We have 12. And then this 1 over 8 is 4 over 32. And so we get 12 times 3 over 32. And so this should be equal to 9/8 if you do the multiplication. So take a minute, try one yourself, and see how it goes. So pause and try. All right, cool. Bam. So welcome back. So what you should have gotten, this should just be equal to 1. So this if you calculate, you should get 1 over minus 1/2 x to the 1/2 from 1 to 4. And then this should give you 2 minus 1 is equal to 1. So I won't go over this or how to do it, but we will do another example, which is a little more complicated. Ooh, that looks weird. Let's go back down. Yes. So let's try a little more complicated example. And of course, this has decided to split into 2 lines. So I'm going to write this here. Right? Okay. So let's first figure out what the indefinite integral is in order to help us solve this. So what do we have? We have this. I can just use my rules in order to solve. So we've already seen this problem, yeah? Cosine of x dx. So here, this is just going to be equal to 3x cubed over 3 minus e to the, oops, come on, adjust. Why is it up there? Oh my god. I swear this app sometimes. Why did it move there? Okay, let's move you back down. Here, thank you. So what do we have? We're here, and then this gives us this plus, plus sine of x. And then what we need is a plus c. So some teachers will actually have you do something like this. We'll have you do plus c1, plus c2, plus c3. And technically this is slightly more correct, but what I'd like to do is just put them all together, do this, and call this c. So I just have one constant. Some teacher, I allow this skipping of step. This is one of the few times I'm okay with skipping steps. Some teachers are not, so you're just going to have to take it by the instructor and see what they say. But just note that sometimes they will have you break this down into little steps. So how does this help? Like you said, you're like, Aram, you said all this, but how does this actually help? Well, how this helps is when I take this integral, right? Now notice how when I did this top thing, I didn't have to worry about substituting every single tiny little thing. I just found one big antiderivative. So what this means when I do this, I already have this antiderivative, right? I have this. So what do we have? Here, I can even cancel this. What we have is x cubed minus e to the x plus sine of x. Remember, I forget this plus c. And I take all of this from 0 to pi. That's it. Like, that was so much easier than having to do this multiple times, yeah? And it looks nicer. And so here, I'm going to put this here so we have room. Let's plug this in. We get pi cubed minus e to the pi plus sine of pi minus 0 cubed minus e to the 0 plus sine of 0. So this is 0, this is 0, this goes to 1. So we get pi cubed minus e to the pi sine of pi is 0 minus e to the 0, which we said is 1. So we get this. Yay! And so now, what time is it? Actually, I think it's about enough time. So tomorrow, our last class, we're going to go over one of the a super confusing way. Not super confusing, but like it's not it's always weird the first time you see this. This will be in the mini quiz. I do have a question that requires this way of doing things in the mini quiz. And so I do want to go over it. It's how long? It's not too long, I don't think. 1, 2, 3, 4, 5. Yeah. We might not have enough time on Wednesday to follow it. I'll definitely finish it. And then maybe on Friday, what I'll do is I'll probably finish our topics. We need to finish up to even and odd functions. So I need to finish this as well. So I might start Friday. Ooh, Whoa, that's weird. Why is it like this? I might start Friday on even and odd functions if we haven't gotten to it yet. So as always, if there's any questions or you need me for anything, feel free to reach out. If this was confusing, let me know. And we'll go over things in more detail on Wednesday on substitution, which I can't spell. Substitution. And we'll go over that. So have a good day.